Hey guys, welcome back to the show. Since I've got this Dentron Clipperton L, I've really been wanting to give it a try on HF. However, being the pretty much all original, all but the parasitic board and the RF choke has been updated. This thing still has the old filter capacitors and diodes and resistors installed, and you know, with running this thing on 220 volts, it's a little scary with such old components in this thing. So I'm going to upgrade the power supply in this Clipperton L. Now another thing I had mentioned before was input impedance, and I was looking for a CM1 to go in front of this amplifier, and my buddy Courtney happened to find one, and what this is a tune input 10 through 160, and it's made for the Dentron amplifiers. Now inside is a set of coils and capacitors for each band, and there's a relay inside, so you can connect this to your exciter. You can run your exciter input, output to the Dentron, and you can set it up so when you key the microphone, it switches the appropriate band input tuning coils into the mix, and that way your radio sees a good match. Well, you basically put this in between the radio and the amplifier, and you saw, like, if you got this set to 20 meters here, you would set this to 20 meters, and when you hook it up and key the mic, this relay inside will kick in and put that 20 meter coil in series with the radio and amplifier, and the radio will see a good match. Well, after further investigation, this thing has 572Bs. The input impedance on the 572B is about 215 ohms. Well, Dentron put 4 of them in here, so if you take 4 and you divide that by 215, you'll come up with about 54 ohms. And that's not bad. I mean, that's pretty close for your older radios. But these modern radios, especially the SDR type, or like the ICOM 7300, they want to see a good match. So this should help with getting a good match to that radio. But we'll get a little more into this later on, probably in another video, because I don't like using these modern radios to key up other equipment, because they're so sensitive and you can blow little transistors out of the radio. So this will be keyed with a foot switch, which in turn will key the amplifier. One thing I'll have to do is add an RCA jack on the back of the amplifier to the 12 volt circuit, and that'll tie into here. Your foot switch will tie into here, and this will go out to your relay input on the amplifier. So yeah, we'll have to put a chassis mount RCA connector on the back of this amplifier to plug power in, but we'll do that in a different video. The main goal of this video is to get this power supply upgraded. So as we look here in our amplifier, we can see that the suppressor board has been replaced to a new upgraded style suppressor board. So ain't no problem there. And I was thinking that the RF choke had been changed, but after looking at it, it is an original style RF choke. So that has not been upgraded, so maybe I need to order a replacement RF choke and put in there. But you know, there's something you don't have to worry about. This one looks okay, so we might just order one to have it on spare in case something's wrong. But yeah, it is good to see that they have the new suppressor board installed. However, looking at the power supply, you can see that this is the original power supply that's in this amplifier. And so you have 8 capacitors, a bunch of diodes and resistors and stuff on this board. And I sat down and figured up, by the time I ordered all new capacitors, new diodes, new resistors, I'm going to have quite a bit of money just tied up in that. So instead of doing that, I just went over to the amp guy, and which is Hardblock Electronics, and ordered a kit for this amplifier. We have a instructions. Have a brand spanking new PC board. Here's all our new diodes. These are 100k ohm resistors, 1 meg resistors. There's a 1000 UF at 50 volt capacitor, and this is a precision resistor, 0.05 ohms at 1%. And also we have brand new filter capacitors. And these are Rubicons. They're 450 volts by 330 UF. And we have 8 of those. So that's all our components, our circuit board, and we can go ahead and get this thing built up and we'll get it installed. Now, the price of this kit at the time of purchase was 125 bucks plus shipping. So yeah, you can't beat that, guys. That's not bad at all, especially for, you know, what it's going to cost you to buy all this stuff separately, and you're not going to have a new board. You're going to have to use the old board. And the way I understand, there is some upgraded stuff with this new board over the old power supply. Plus, it's not going to take up quite as much room inside the amplifier as the old board did. Alright guys, I got our circuit board mounted in our panel vise, and I have our layout here. And it's always best to start with the low components, the shorter components first. Then as you build the board up, you end up with the tallest components. This works good if you don't have the panel vise and you're just working on your bench. So we're going to start with R23, and R23 is that 0.5 ohm 3 watt resistor. Now, another thing you need to remember when building boards like this, resistors and diodes get hot. And when they get hot, they can scorch or, you know, burn the circuit board. So it's always a good idea to keep your components that generate heat about 1/4 inch up off the board. And we'll do this with a variety of different pieces of 1/4 inch balsa wood. Like for R23, we'll set this here, and we'll put it in the board, and that will keep it from setting right on the board. So when we put it in, it will be just perfect. Anyway, we'll start by looking at our component, seeing where it's going to line up. That's how I like to start. I'll take a pair of needle nose pliers, if I get my component centered, I'll just take a pair of needle nose pliers, bend the end down. I have another piece of balsa that's already marked. I'll do the other end about the same. Bend it down. Now it should fit that footprint without any problem. I'll lay a balsa strip underneath of it. And since this is a single component, we'll go ahead and solder it in there. I'll put a little flux around it. Have that component in place. And that's pretty much how I'll do all of them. So you can see the component is up off the board. So if it gets hot or blows out somewhere down the line, it will not damage the circuit board that bad. So our 20, 21, and 22 are our 1 meg ohm resistors. They'll go in this position. There's 22, 21, 22, and there's 20 over here on the side. So we'll go ahead and I'll bend these and get those put in. Alright, I got all 3 resistors bent. I'm going to lay my piece of wood down. And put some flux on these. And solder them in place. We'll take our last 1 meg ohm resistor. And what I do is that I'll always reach under here and bend the legs so that it holds it onto the board. To me, it makes it look nice having the components up like that. Now we'll go ahead and we'll do the same thing with our 100K resistors. We'll get all those bent and they'll go in, let's see, I think it's R12 through 19, and then R24 gets one over here. But you see the gist of it, so I'll go ahead and get those done and put in. So if I'm doing the same components over and over as far as bending the leg, after I figure out my spacing to get the resistor centered in the silk screen, I'll make a mark on my needle nose pliers. You know, your needle nose pliers are tapered. So if I come right here and bend that leg down, then go to the other side, put it in the same spot, and bend that down, then my resistor is always going to fit perfectly in that slot. And on these type of resistors, I'll just run my little stick all the way through. Reach in here and bend the leads. And then solder those in place. So when you're soldering, you know you're soldering on the back side of the board. These are plated through holes. So make sure that when you go and inspect, that your solder is flowing all the way through. Now I have 3 joints here that did not flow through. This one, if I zoom in on it, you can see there's no solder on this side of the board. And this one and this one. So those two have very little solder on this side of the board. Just to make sure that solder flows all the way through. So you can see these two now have solder all the way through the board, and also the one here on this end has solder through it. This way you make sure you get a good connection. So all we got left is our high voltage diodes and our capacitors to put in. Now when you're doing the diodes and the capacitors, you got to make sure you get the polarity correct. You see the stripe on this end will match the stripe on the PCB. That way you get your anode and your cathode in the correct location. Now we got all the diodes in. Now remember the diode, the leads are thicker than what it was on the resistors, so it's going to take more heat. So you need to raise your heat up a little bit on it and make sure the solder flows on both sides. Now what I want to do is go ahead and pull the board out. I'm going to go ahead and cut off all the leads and clean the board and get all the flux off before we move over to the capacitors. Alright guys, all the passive parts are on. I've got the flux cleaned off the board, and come to find out I was out of chem wipes, so I had to use paper towels, which, you know, they come apart and get stuck all to the clipped off components, but it is what it is. I've got to make an order for those. So now it's time to install the capacitors, and this one is a Nichicon and the big ones are Rubicon. So use some pretty decent capacitors. Again, when you install the capacitors, note polarity. Negative goes to the negative, positive to positive. Try this without putting flux on it. Alright, so that was that one installed. And then the big capacitor, you got your negative side and your positive side. The board is marked positive, so you make sure the positive is put into the right hole. We'll have to put a little flux on these. Now another way you can tell is the positive is a square and your negative is a round. Same thing on the back side, so you can see it. So I'll go ahead and pop all the caps in. These kind of lock in place. So they'll stay on the board. Alright, we can go ahead and get all these soldered in. And once then, I'll bring you back. And there we have it all. New power supply board. It's all built up. And what we need to do now is go ahead and start removing the old board and marking the wiring and getting it ready to accept the new board. Now again, I went back and I verified all my solder joints look good. I verified all the polarity of the diodes and capacitors to make sure they're in correctly. So shouldn't be no problems with this then. Alright guys, now it's time to go ahead and start disconnecting the wiring to the old PC board. And the first thing that we're going to start with is the high voltage meter switching circuit. You have one red wire here that goes down to the PC board, and here you have this blue wire that comes from the end of this resistor string. These are 1 meg 3-watt resistors. There's a 100K resistor under here that goes from this first resistor to ground, and this wire we will need to disconnect here, and we're going to label this wire HVM, this high voltage meter. The red wire we won't even use it at all. Now when we get this done, we'll take this completely off because this string is no longer needed on our new board. That's what this string of 1 meg resistors here are for, and you see that's all 100K resistor. So when we get this in, this blue wire will need to be changed out, and it'll go here to HVM. Okay, so I got a little blue wire clipped off. I got a piece of tape on it, and I have it labeled HVM. And we'll have to put a new longer wire on this. And what I'm going to do, I'm just going to loosen this up. Get this screw and washer, and we'll put that doorknob cap back on. Alright, so now we're going to stand the amplifier up on this side, and we want to find the red wire that carries the B plus, which is going to be here, to the RF choke, which is going through here, and that's going up to the RF choke. So I'll make a label that says H, B, B plus. High voltage board positive. And we'll just take that, put it right around this wire. And I'm going to just clip it on the board. So as you see, we clipped it from this point. You follow this red wire, it goes right down through one of these grommets in this shield just underneath the tube into the RF choke. So normally there would be a large red or yellow wire and a large orange or red wire down here, but someone has changed out this transformer, and they went with a bigger transformer than what came in it. You can see there's the original 2 mounting holes, and these are the 2 new mounting holes. So the issue with that is that our wire colors does not mate up with what we already had. So what I'm going to do, I'm going to just snip the green, I'm going to snip this yellow, and I'm going to snip this brown wire, which I think was originally yellow. And this way I can go ahead and get this board out, and we'll be able to trace all this wiring out through the transformer, so we can get it all connected back up correctly. Because we'll be able to reference the wires with the other wires where they're going at. This just makes it a little easier. So inside here, going over here at the back, there's a black wire that comes up to this meter switch, and on the other side there's a white wire, and it comes up and goes to this LED that's in the meter, and I'm going to need to clip those out. I can get down here to it. There's the black wire. And there's the white wire. And there's one other wire here. That's a red wire. That goes to the PC board on this end. I'll need to clip that one out. And I see another problem with this big transformer. It's hanging over the board. So normally what you would do is slide this forward just enough, and you would lift the back of it up. But that's not happening because the transformer is hanging over this board. So let me play with that. Well, guys, I got the board out. I had to remove the single sideband CW switch out of the way. I had to pop the power and standby switch out the front, and I had to loosen up the bifilament choke over here to get this board out. It was kind of tough, but it is now out. Alright, with that said, hopefully our new board will go in a lot easier. What kind of made it tough was these capacitors are so tall, it's hard to move that board to an angle. But you can see just how far this transformer hang over in there. So I'm thinking on new board the diodes will be towards the front, but I'm thinking it's going to just drop right in. Get it past the wiring, and there it is. Right in with no problems. I'll go ahead and get this bolted in. Okay, so I got some of the wires labeled. This is the one here that goes to the single sideband CW switch, and it was connected here on the old PC board. This will go to
station alert has arrived.
X2 on the new circuit board, which is down here between the center of the capacitors. We got B minus. This goes to the meter switch. It's going to connect to B minus on the board. High voltage meter is going to connect to HVM on the new board. There's another wire here, and this is actually something that was added. Someone's put in some LEDs on the meter, so we'll have to hook that to low voltage DC input. On the bottom side, we have the B plus, and that's going to go to the B plus hole. I got two wires here I've got to sort out. I think one of them is low voltage AC, and the other one should be transformer 1 from where I look. And then we have this green wire here, which is going to be low voltage DC, and that will operate the lights on the front. So we'll go ahead and get those connected, and we'll sort out these other wires. So just remember, guys, whenever you're doing something like this, don't always expect for it to be exactly what you'll find in the instructions. I mean, just looking here, see the wires that carries the plate voltage B plus from the PC board to the plate choke, usually red or yellow. Could not be the case. Could be different. And this transformer, it happens to be red. The large brown or orange wire from the transformer almost always spliced to a different color, usually light green. So see, even in the direction, it tells you that there were some changes in the factory when they built this. But when you get one that someone's added, like these meter lights, and changed out the transformer, your wiring might not always correspond with what's in the manual of the part that you're installing. So you'll have to reference the schematic and look at what's been changed. Okay, guys, so I went ahead and traced out the wiring. The bigger yellow wire that was here, remember there was two, a big one and a small one. The big wire is actually transformer 1, and transformer 2 is hooked up here. So we figured that out. The small wire is your low voltage AC. So I ran it back up through the hole, come around and connected here to low voltage AC. This is our low voltage DC going out, plus our B plus here. After I get everything buttoned up, I'll go back and remove the tape that labeled the wires. So here on the top we can see coming from the single sideband CW switch, X2 goes down to the middle. This wire is not connected yet. I'll connect it once I verify that it's not, the voltage is not too high for these LEDs that's in there. Sometimes it could be, you know, depending on the transformer, after rectified and filtered, it could be as high as 20 volts. So we don't want to throw 20 volts to those LEDs, which even though they got dropping resistors in them, still we want to make sure it's right. The only wire that, other than the LEDs, that hasn't been connected is our high voltage meter. So we're going to take a new wire and we'll solder there and connect to the board down here. So I'm going to just strip back this end of the wire. And we'll stick it down in the high voltage meter hole. Wedge it under those components to hold it. We'll flip it up. There it is right there. some flux on it, and we'll solder that to the circuit board here. There we go. Clip off the access. Now all I need to do is desolder this terminal. Go ahead and tin this. And we should be able to solder it right back to where we pulled that wire off of. There we go. And again, that should complete installation of the power supply board, with the exception of that LED wiring. What I'm going to do now is we're going to go to ground. We're going to check our B plus here, make sure there's no shorts to ground, and we're way up in the mega ohms. We'll go from transformer 2 to ground. We've got a good high reading there. Go from transformer 1 to ground. We'll go to our low voltage AC to ground. And that looks good. Low voltage DC won't really matter, but okay guys, mistakes were made when I was checking with the ohm meter. I didn't catch this, it just didn't dawn on me, but I went back and was looking at the footage, and I noticed that when I went to transformer 1, I had very, very low, like 3 ohms or something. So I end up having to pull the transformer out, and wanted to get this wiring right, and I actually had this wire going to low voltage AC and this wire going to transformer 1, which is completely wrong. The 2 big wires, that is your low voltage AC. This wire and this wire is your high voltage AC. This wire is your high voltage center tap. So yeah, if I would have powered this up, it probably would have blown the fuse. But you know, it's always good to go back and recheck. And when I was sitting here thinking, I said, you know, something didn't look right. Transformer 1 went to ground. I'm thinking some of the old amplifiers, actually one side of the high voltage is grounded, but when I went back and looked at the schematic on the for the amplifier, it is not grounded. And I actually looked at the schematic for the replacement power supply. So you got one transformer winding at the center of the two strings of diodes, and the other transformer winding goes to the center capacitors. So yeah, that could have been a mistake, but at least we caught it. Alright guys, so other than the wearing mistake I made before, which we caught, this is fairly simple process to do. This wasn't hard at all. With the oversized transformer and the different wiring on it, made the old board hard to get out. I probably could have pulled the caps off of it, and that would have made it easier. So you can think about if yours has been modified like this, you might want to pull the caps off instead of taking all the other stuff loose. Either way, it's not that bad to do. Your high voltage meter wiring goes to HVM. This is one side of the high voltage secondary. This is the primary. This wire coming off the bottom of your switch goes to transformer 2, and that's all on the top side. Your B plus out connects here. Your other high voltage winding on the secondary goes here. Your low voltage AC goes here, and your DC out connects here, and that's pretty much it. So everything ohms out okay, so it should fire up and have everything we need. I'm going to place the top cover on so that it'll push the switch in the back. We'll plug it in. I got it wired for 110 at the moment. We'll turn the AC on. I'm going to keep my fingers down here in case something goes wrong. Doesn't really matter about these. We'll start off on low voltage. I see a meter's a little bit out of adjustment. Go ahead and adjust that, and we'll turn it on. Okay, let's try that again. There we go. We're showing about the correct voltage on SSB. We'll see how low voltage is working because our power light is on and our meter lights are on. We'll go over to SSB. High voltage come right on over. So yeah, all that's looking good now. It looks to me like it may be a little, the voltage may be a little high. As you can see, this lamp looks kind of bright. As long as that lamp doesn't get too hot and start melting our lens, we'll be okay. Guys, whenever you're messing on something like this, be very careful. You can see right now the voltage is still up on the high voltage, so be very careful working on stuff like this. We'll set this over to DC. I just want to see what that voltage is. We're showing about 14.9 volts. And look, our light just blew. Yeah, I got a lamp out. These 328 lamps do not like voltage that's much over. I mean, this is a 12 volt lamp. It doesn't like at 14.9 volts, and it's already blown it. Okay, so if we check the voltage with no load on it whatsoever, we're up at 17 volts. Easiest way to drop this, you can put a resistor in it, but this is a 7812 12 volt regulator. We'll connect our voltage source to the input. We'll go to ground, and then we'll go to output, and we can see now our voltage is down to about 10 volts, which should run that lamp without any problem whatsoever. So we can mount this in. We'll probably put a couple of small caps on each side of the transistor, and that should solve our voltage going to the lamp. The relay, it don't care. They'll work anywhere from 10 volts to 17, 18, 19 volts. It won't bother the relays as bad as it does these little lamps. Alright guys, so I came in here and I mounted the 7812. This is where that terminal strip that had the 3 1 meg resistors on it was there, and I just put that 7812 there, so that should get our voltage back down far enough so we don't have to worry about blowing those that 328 lamp. So I want to run the CM1 with our Clipperton L, and if you look on the back of it, RF from the radio goes to input, out goes to input of the amplifier. If you look here, you got 12 volts DC, exciter key, and linear key. And what I want to do, instead of having to run a separate 12 volt wall wart or whatever, was get power directly from the amplifier. And I had even ordered some more chassis mount RCA jacks, but I was looking on the back of this amplifier. You can see this is the jack here. It's for your relay inside the amp. So if you're going to run it, this would go to your radio, which I'd never use. I always use a foot switch. So you plug your foot switch here. I started looking, there was already an RCA jack here. So I get in here and I start looking, and I notice this big wire right here, and that is actually going from where I would pick the voltage up at to this RCA connector. But I don't know why they use such a big wire. I'm going to desolder that and put something on there a little more manageable. It's like they're trying to bring in high voltage, but yeah, that's a little bit overkill. So from this terminal that it was connected to the center of the RCA jack, it's not even a 1/4 inch. So I'm going to just use a clipping off of one of the leads from the resistors we put in, and I'm going to just solder that right across it. There we go. Now we'll have our voltage going to our jack, and we'll have that big hunk of wire on the top of it. Okay, so I just grabbed a random cable here in the shop, and we're going to use this just for testing purpose. So I'm going to plug the white in the relay and the red going to go into our voltage out. And since that is not quite 12 volts, I'm going to just make a label that says low voltage DC. And we'll stick that right under here. LVDC. That's low voltage DC. So on the back of our CM1, we'll plug the red into 12 volts. The white will go to linear key, and then I have a foot switch that'll plug into exciter key. And I'm going to pull the screws out of this just so we can verify the relay. That was really weird. This screw head was wobbling all over the place. I don't know if y'all can see that, but when this screw was machined, the head is over to one side. Okay, now I should be able to see the relay to make sure it activates. And I'm going to drop the foot switch in the floor. We'll go ahead and power up the amp. It is plugged into a dummy load, but that doesn't matter because we don't have an exciter that's going to charge up anything. I'm going to operate, and when I step on the foot switch, we should see the red light come on and should see that relay engage, and it does. Alright, we're good to go on that. Alright guys, there we go. Our Dentron Clipperton L should be set up to run quite a few years without many problems. I do want to pick up a extra set of tubes. I don't like the new Russian tubes, especially in an amplifier where the tubes are laying down. I have seen those Russian tubes, the filament gets so hot that it actually sags, and when it does, they'll hit the cathode and short the tubes out. So hoping I can look around and run it to a good set of strong used tubes, and just to keep on hand, because this was all the 572Bs I had. And as far as the old power supply board, I'll hang on to this. I mean, it works, there's nothing wrong with it, but could be a chance where someone has one that had a major catastrophe and, you know, burnt the board up. So that's a good board I could use as a replacement. And, you know, if they don't want to spend the money to put the new upgraded board in, the old ones will run fine if you got new capacitors and new components on them. So, you know, it's always something to think about. We just don't pour these out and chunk them away, because they can be used. Alright guys, hope you enjoyed it. Please leave your comments down below. If you got something out of the video, hit that like button, and if you haven't subscribed, please do. It helps with the channel. Anyway, we'll catch you guys in the next video. Bye now.